In the previous video lecture, we discussed about the voltage divider rule. Now in this video lecture, we will be discussing another important example which is related to the voltage divider rule, in which a DC voltage source is connected in series with three resistors R1, R2 and R3. And V1 is the voltage drop across the first resistor, V2 is the voltage drop across the second resistor, and V3 is the voltage drop across the third resistor. And the potential difference across the terminals of this DC voltage source is 60 volts. And the resistance value of this first resistance is equals to 2 times the value of this R3. And the resistance value of the second resistance is 7 times that of R3. And we are asked to find out the voltage drop across the first, second and the third resistor. Now for that, the voltage divider rules states that Vn, which is the voltage drop across the nth resistor, is equals to E divided by RT into Rn, where Vn is the voltage drop across the Rnth resistor and E is the input voltage and RT is the equivalent resistance of the series combination of resistors. Now first of all, we need to find out the total resistance or the equivalent resistance of this series circuit. So the equivalent resistance of this series circuit is equals to R1 plus R2 plus R3. So R1 is 2R3 plus R2 is equals to 7 times that of R3 plus R3. So the equivalent resistance is equals to 10 times R3. This is the equivalent resistance of this series combination. Now first of all, we need to find out the voltage drop across R3, because R3 is already given to us in the equivalent resistance. So according to this formula, V3 would be equals to E divided by RT into R3. So V3 is equals to E is given to us, which is 60 volts, divided by RT is 10 times that of R3 and R3. So R3 will cancel R3. So the resulting voltage drop across the third resistor is V3 is equals to 6 volts. So the resulting voltage drop across the third resistor is 6 volt. Now the voltage drop across the second resistor would be, let's say V2 is equals to E divided by RT into R2. So V2 would be equals to E is 60 volts while RT is 10 times that of R3 and R2 is given to us, which is 7 times R3. So the resulting voltage drop across the second resistor is equals to 42 volts. So here we have a 42 volt of potential or the voltage drop across this second resistor. Now the voltage drop across the first resistor is, let's say, V1, and V1 is equals to E divided by RT into R1. So V1 is equals to E is 60 volt while RT is 10 times that of R3 and R1 is 2 times that of R3. So R3 will cancel R3. So the resulting voltage drop across the first resistor is 12 volts. So it's all for today's presentation. If you have any doubt, ask in the comment section. See you in the next one.